Hello, my name is Pcholkina Mariia, and the topic of my work is space weathering signatures in the Vesta family according to a photometric surveys of SDSS, SkyMapper and Gaia. Space weathering is defined as a series of processes that modify the optical properties of the surface of objects exposed to open space and unprotected by the atmosphere. It is manifested on atmosphereless bodies by a decrease of albedo, an increase in the slope of the spectrum, and decrease in the visibility of absorption bands. For lunar regoliths, physicochemical processes have been studied quite well. For asteroids of various taxonomies, the situation remains largely unclear. Since the formation age of asteroids of the family can be considered the same in the first approximation, the age influence of high-energy cosmic rays and micrometeorite impacts will be approximately the same for asteroids of the same size. However, the families have a known extent along the heliocentric distance. Assuming the linear type of cosmic weathering, it can be expected that the asteroids at large diameters should have less weathered surfaces. It can also be expected that the smaller bodies have a younger surface. Therefore, for such bodies, the albedo and the depth of the 0.9 micrometers band should be larger, and the spectral slope is smaller for the asteroids located closer for having larger sizes. In the study, we concentrate on Vesta family because it is one of the most numerous families. The asteroids belong to a specific taxonomic type V, which is characteristic by a deep absorption bands of pyroxenes at 0.9. And the age of the family is estimated at 1 billion years. And the surface material of Vesta is known quite well from the head meteorites. However, the extent of the family in distance from the Sun is 0.2 astronomical units. Since the However, the extent of the family in distance from the Sun is 0.2 astronomical units.
IZ color index allows us to estimate the depth of the pyroxene band, and the slope of the spectrum outside the band can be determined using the color index GR. The dependencies of the color indexes GR and IZ on the semi-major axis and on the diameter is the three datasets SDSS, SkyMapper and Gaia were analyzed. Moving to the results, the dependence of IZ color index on the heliocentric distance is visible for all three data sets and corresponds to the expected one. With the increasing distance, the depth of the band increases. The dependence of IZ color index on the diameter of asteroid is visible only for SDSS and SkyMapper datasets. The color index GR has a less pronounced dependence on the distance, and color index GR decreases with the growth of the semi-major axis. This is no actually significant dependence on the albedo of the distance and diameter. So, in our work, we proved that the asteroids of Vesta family and similar signatures of the cosmic weathering to lunar regoliths.